So before we even get started, so you said we were talking about IoT systems at TechPoint.
Yeah. I remember that actually. I think it was
Okay.
about maybe 3 years ago now, right?
Yes.
We had a an exhibition booth, right? At and we had so many people come to us, and then you were one of the people. Actually, I think you really criticized the entire project in quotes in terms
Okay.
of
What was the project?
no, it was we had this board. We designed
Okay.
this this a board, American controller board around ESP266 chipset.
Okay.
And so we wanted and then we had this software, right, that you could use to like program the microcontroller board, more like a substitute to Arduino, right? And but much more friendlier to learn and stuff like that because they are
Okay.
blocks that you could just like put
Okay.
together. Yeah, so yeah, but I think your challenge with it was an industrial use case for it, right? You're like, okay,
Okay.
you look at Raspberry Pi and stuff like that, which, to be frank, we all were just like, oh man, and at that time, um, you, you were popular in the ecosystem, right? As
Mm-hmm.
in, I think you came from Kaduna, is it Kaduna or something? From the northern out.
Yeah, possibly. Yes.
Yeah, I
Yeah.
don't know,
I
but it
must have
was
come in from
just
Kaduna.
you were one of the I think was it not this
Speakers.
Google and all this you had this
Yeah.
Google certified something
Yeah.
back there. Yeah, and it was
Yes.
yeah. I think yeah, it was actually out there. Quite a number of people knew it and stuff. So it was like you talking about it, and it was good. Honestly, it was good. It was a nice experience actually having a conversation. Yeah.
Okay. So I'm interested, based off of the questions that I asked, right? So you've had 3 years to prove whatever you were doing. So the
Okay.
questions that I asked, did they turn out to be valid?
Yeah. Especially the part of the scalability and and that the scalability essentially the fact that we couldn't make it big, right?
Okay.
The fact that the idea was somehow not as authentic as we thought it was, pretty much. So yeah, 3 years down the line, I've learned quite a couple of things, right? So the idea before was to to sell the boards, to sell boards that people could use, and students could use it and stuff, and then but it wasn't really authentic because if we look at the bigger picture, how many people are actually interested in wanting to get one of all these things, right? So far so good. We sold about 70 boards, 70 actually, and we're even still selling. And the fact is, I'm not as impressed as I wanted. I felt like we could actually go very far with it and stuff, but we couldn't, right? Because of the scalability issue. We're building something for the educational system, which actually is lacking in quite a number of things. Not so many people are interested in all this kind of stuff, and the idea in itself has a bit of weakness in it. So it wasn't authentic enough, and if we had probably maybe designed for an industrial space, maybe right, we'll probably be in a better position at this time, right? Which was actually the conversation that we had then was, okay, why don't we just do an industrial stuff around this instead of just doing just educational, you know? And so pretty much I've learned, yeah, we've learned myself and my co-founders, yeah.
Okay. So, the interesting thing, I think I usually try to ask questions from an unbiased perspective, right?
Mm,
Which is to either say, how is what you're doing comparable to something else that I might have heard of or
Yeah.
read about
Yeah.
or used. Because when you talk educational, I'm thinking, okay, BBC Microbit, for example,
Yeah.
is
Exactly.
one board that is targeted at that level.
Yeah.
And yeah, I haven't got one. I've been contemplating getting one just so that I see what exactly it is.
Yeah.
But I haven't got my hands on it. But when I read the documentation on the site, they support Scratch, I believe, for
Yeah.
programming the microbit, right? Um, of course, the actual silicon on the BBC microbit is different from the
I think
expressive that you are using.
STM32 that's on it. STM32. STM32.
Okay,
That's what's on
okay.
it.
So that's what is on it. Okay, yeah. So that the architecture itself is completely different.
Yeah.
But I'm thinking, so if you were to reboot that project now,
Yeah.
what would you do different?
Okay. Okay. What would I do different? Would actually be to design a product around it. So
Okay,
after about a year after, right, when we noticed that some things were not working, right, we pivoted into actually using it to do industrial solutions. So first of all
okay,
was battery monitoring systems. So we started
okay.
off with, helping companies, banks, right, to monitor their
Mhm.
data center batteries, right. But we started noticing something about the board. Right. First
Okay,
of all, was that it wasn't fit for the industrial use case because we couldn't tweak it to a lot of things that we needed to do. Right. So we ended up using some Orange Pis and Raspberry Pis as our gateways. Right. Because
okay,
we needed a full Linux system to be able to talk. To be able to talk to those inverters, right, and those UPS, right, pretty much on SNMP and also do some Modbus communication with those like high-end devices. So we struggled and we wanted because we already had a huge stock of Event One, right, bulbs, right? So we're like, come on, if we could just make this thing work for it would just be a no-brainer, right? But it didn't work as we wanted it to because we needed to run some complex stuffs on it. And there were times that we tried so hard, but then it just does this resetting and stuff when it gets heated up. So yeah, so if we had focused on on an industrial point of view, we probably wouldn't have settled for ESP. And even if we had settled for ESP, we would have designed the board even far better, right? Um, so we went on using the Orange Pis and the Raspberry Pis, and yeah, so it was a different company, right? And then we brought in all the technologies that we use, the IoT tech that we had built, this whole IoT, tech that we had already built on top of the Event One. We basically then, just formatted it, made it friendly for our Linux mini devices, and yeah, it worked. It worked. It still works up to now, right? We have a number of customers, banks actually, right? That because we also have a dashboard that allows them to see the usage of their battery downtime, gets alerts and all those kind of things. Yeah, so pretty much that's it.
okay.
So
That's
if
interesting.
industrial use case, pretty much that's the answer to the question.
Okay, all right, nice. So let's get into the interview,
Yeah,
and so I'll just do an intro, and then we'll get started.
yeah.
So, hello, viewers. Welcome to another episode of my interviews with embedded systems engineers. Today, I have Victor on the call, and I'm going to go straight to my first question, which is, Victor, how would you introduce yourself?
Okay. My name is Victor Shoaga, and I'm an engineer, pretty much, right? Yeah, and I've been doing embedded systems for quite a while, right? And I've also, I've been working on software quite a while as well. So yeah, I don't know. Yes, pretty much. Yeah.
And in terms of duration, how many years would you say you've been an embedded systems engineer?
Okay. I started out around 2012. So yeah, 20. Yeah, probably 9 years.
Okay.
9. Yeah, yeah.
What schools did you attend?
Oh, okay. My from like primary school, Royal Christian College in Mushin, Lagos is a very funny place to call around people and say, you schooled in Mushin and stuff. But I did. I also I I I had my university at Obafemi University. I schooled at Obafemi University, and that's in Ilefe, Osun State. I did electrical electronics engineering. Yeah, I did electrical electronics engineering pretty much. Yeah. So
Okay,
yeah,
so you schooled in Nigeria. Here's a
yes.
context. Here's a context for why these backgrounds are important for viewers.
Okay.
A lot of the time, people feel that you can only be successful if you go to the best institutions. And we're not saying that going to good schools
Hmm.
isn't good, but
Yeah.
the excuse should not be that I can't do what Victor is doing because Victor went
Yeah.
to better schools, right?
Mm,
So
yeah.
part of the
Yeah.
narrative is when we say, what schools did you go to? And you say, oh, I went to school in Mushin. Then someone who went to school in Mushin wakes up and says, oh, I just had my area
Uh,
called. So now I don't have any other excuse, right?
yeah.
Um, yes. And I know OAU has produced some pretty good students.
Yeah. Yeah.
It's a good place to come out of.
Yeah.
So tell us, Victor, how did you get into this field of embedded systems?
Okay. So back in 2012, actually, I started programming in yeah, at the around the middle of like say mid 2012. Probably that's when I started coding, and I actually started coding Python right back then. It was interesting. It was very interesting, right? Because I was the only one back then in my room, right? That was programming, right? That's my hostel in the university. We were programming. All my friends back then, I'm still connected to them, by the way, today. They were like, "What this guy? What are you doing? What are you building?" And blah blah blah. It was a very interesting thing for them, right? It was one of those moments I still relish the fact that just typing the hello word from the interpreter typing hello word literally gives a lot of people right this happiness, this joy, right, and stuff like that. So I started programming mid 2012, and towards the end of 2012, I met a friend, right, who was very good with embedded engineering, pretty much any systems. It was focused on microelectronical chips back then. That's the peak, the PIC guys, right? Yeah, yeah, it was doing crazy stuff with it, pretty much doing a lot of projects it was doing a lot of projects for our seniors, for master guys. It was doing projects for them, and yeah, I wanted to learn it so bad. Like it was like, okay, this is like next thing. Well, obviously, Python that I had learned already wasn't even the fit for it. And so I got books. I got some the art of electronics books, and teaching us the basic, running your pull-up switches, with resistors, transistors, how they really work and stuff like that. How you can make them switch virtually anything, just build your systems properly and stuff like that. Yeah, and then I went back to him, and then he showed me this micro C. So he had this like this IDE built by Microelectronic as well. That's micro C that he was using to code the PIC chips and stuff. So yeah, it was just like one day he showed me how to use micro C, and boom, I just started using it. It was very interesting. Like it was me going from Python to C, and C was very interesting back then. Yeah, and yeah, so that was pretty much it, really. I went to his place at night. There were times where we were doing like, all nights, trying to like, make some things work, make some bulbs turn on, make some switches click, blah blah blah, and stuff like that. Yeah, it was good. That was pretty much how it all started actually.
That's an interesting introduction. It highlights the importance of having the right sort of people around
Yeah,
you, because you saw him do something,
yeah,
you decided that it was something that you wanted to do, and
yeah,
thankfully it was a positive thing,
yeah,
and you surmounted all of the challenges. I like the fact that you had to go out and get books. So
yeah,
even though he had the controllers there, you had to go get the books, learn
yeah,
some other things before you got into it.
yeah.
So currently, where do you work?
I work at Kudi Inc., a company in Nigeria that focus on financial service, providing financial services for customers. And what I do there, the company is writing applications for the POS devices that helps us to, process transactions from customers.
And how long have you worked in this position?
In the company, you mean with the
Yes,
company? Yes,
yes.
a year and a year going to a half now. Pretty
Okay.
much.
So 18 months.
Yes, there.
Okay. So you mentioned that the company is providing financial services and you're programming POS terminals. Can
Yes.
you tell us what POS terminals you're working with?
You mean the brand?
Yes.
Oh, okay. We work with Asino devices and also Morifone devices as well. Yes, pretty much. Yeah.
So interesting question. Have you ever looked at the specifications of these devices?
You mean the software specifications or the hardware side?
The hardware specification.
Okay, the hardware specification. Yeah, the only thing I've looked at it has just been the normal device specifications that shows the memories, the memory.
Okay.
Not the ones that show the you know the device packaging itself, the
Okay.
plastic. It's just the device specification I'm focused on is just the one that shows the memory, the things. Yeah, pretty much memory of the devices that shows the RAM and the ROM that it has, the flash and everything. Yeah.
Okay. So trivia question. Do you know the microprocessors that are in the POS terminals?
So funny enough, right? These guys actually hide it, right? So funny enough, I actually just asked one of the guys that provides it just last week, right? And he
Okay.
gave, yeah. What I know is I know the makers, right? I know for the Morifone, we are using a new device, a new Morifone device that uses a different chipset. That's the V133, and then the one that we currently use right now is I think EC25. EC25. That's one that we pretty much use. And
Okay.
yeah, yes.
So interestingly, I was looking through the NIBS website because they have a list of POS terminals that are certified for use in Nigeria. And I can't remember which is which, but between the Morphone and the ICNO, both of them actually use ARM chips.
Okay, yes.
Yeah, they use the A chips, the Cortex A chips, but
Okay.
different
Yes.
versions of those chips.
Okay.
So you could very easily in one of them have the same chip, or the same family of chip that you would
Yes,
have
correct. Yes.
in a Raspberry Pi, for example, maybe the Model 3 or maybe an older version of the
Okay.
Raspberry Pi. One of the reasons why I ask these types of questions is because of the instruction set architecture that goes
Okay.
in, because there are all sorts of things. Depending on the generation of chip that you have, you might
Yeah.
have some security features or the
Yeah.
ability to run certain types of things,
Yeah. Exactly.
yeah, that you might not have in some places.
Yes.
Now, uh, funny enough, right, when you talk about embedded systems, sometimes some engineers who are involved in programming POS terminals do not realize that they're embedded systems engineers
Okay.
for some reason. Yeah, I don't know why, but they don't. So I'm gonna ask. Okay, so I've talked about the in this case it's terminals and not controllers that you deal with, right? But in terms of writing code for these terminals, what sort of constraints do you have to deal with?
Okay. Okay. So pretty much memory, and number one, memory, and number two is display, right? Memory and display are the major limitations, actually. Um, the regular terminal can pretty much connect to the internet the way like anything connects to the internet. Just socket opening, and obviously on any circuit you can basically pass any amount of data you want to pass, right? And then obviously, do whatever you want to do with data on the terminal. So yeah, pretty much the limitations are just the memory and the display. Memory in the sense that being able to like run multiple things at the same time. When you try to do that, on terminals with smaller RAM, it begins to hang, right? Because there are so many processors running at the same time. Um, yeah, yes, and then for a display, right, you not all of them can display Unicode characters. Not all of them can display some weird characters, pretty much that are not A B C, the normal like ASCII and stuff, so that people are used to. So yeah, pretty much.
Okay. Now, in terms of your IDE, what
Yeah.
IDE do you use for writing your
uh,
code?
I use VS Code. VS
Okay.
Code to write code. Yeah, I use VS Code to write code. Before I use Eclipse. Before I usually use Eclipse, and then I'd use um, Micro C as well. IDE back then. Yeah. Yes. So, but VS Code right now, pretty much VS Code.
Okay. And one of the reasons why we're having this chat is to try and get people interested in this field.
Mm.
And one question that people have when you tell them that there is a job opportunity is how much are they going to be making?
Okay.
So, are you able to give viewers an idea of what an entry level salary for this job would be like?
Okay. So maybe between an entry level would be between 200 to 300, actually.
Okay.
I think, yeah, that's it. And the thing is, or because embedded systems, basically it's very much it's not as dynamic as the regular software programming, right? It's not really, things don't really change that much, right? Except the hardware changes, right? If the hardware doesn't change, pretty much it's still the same thing that runs 6 years ago still runs today, right? Yeah. Yes. So one of the things I typically do, or let me say advise people to do that, like also writing embedded, right, is to basically go into learning software, right, to help them into, of course, improve the pay, right? Because they also have software skills, and also to help become a better engineer in total, become a round engineer. That's what I mean. A, an engineer that pretty much knows what is going on from the back to the front, and you know how your device, you know how you want your device to consume the data, and you also know how you want to send your device out, and you pretty much know everything end to end. And this helps you not just to only understand the device as it were, you would also understand everything that that surrounds the device in terms of the security, what is exposing itself to, and stuff like that. So, and definitely it will also help to improve the pay if you learn other like skill sets. You can you can delve into some some software programming, maybe being able to like build some web applications, not trying to deviate from embedded system engineering as well, but just learn it, right? Not like you're going to be a web person. Just learn it for fun, right? Imagine. So back then, I usually serve. I usually, we had some tutorials on our event one board that was serving some web pages, pretty much, right? So we had right, have like we had built like a web server on the device, and then we would tell someone else to connect to the board via Wi-Fi, and then just you go to slash something, and then you just see a web page on it, pretty much. So that basically gives you the understanding of how browsers work, right? That is okay. They are pretty much just getting something that exists somewhere, right? And where is that thing? It's also on an hardware separate from your system, essentially. So I think being able to it will give somebody a round engineering perspective, and also it will definitely make you give the person more money as well.
Okay, that's really good. And while you were talking about that and giving the example, I just thought about your typical home router
Yeah,
that lets you browse to a certain IP address, well, its own IP address, and then you're
yeah,
able to log in and do all
yeah,
of your router configuration as a normal person here. So they also embed a web
yeah.
server
So
onto those embedded systems as well.
yes, yes.
Now, I was going to ask, so you've been on this job for 18 months. Did you start programming POS terminals on this job, or were you programming POS terminals before you got to this job?
Yeah, so this is the first time I'm programming POS terminals. I've never programmed POS terminals before. I started out program POS terminals October, around October 2020. Yeah, about that was when I started programming POS devices. It was a new field in terms of payments and stuff like that, but I'd I've already been working with hardwares from way back, and I pretty much understand it. And also, I've also delved into the software space as well. So let me quickly give a bit of background. So when I was about like 4 or 5 years ago, I was really, really, really into designing boards. Like it was like I had a full, computer, a full setup, right, that helped me to, not just set up computer. I'm talking about logistics wise as well. I had some folks in China and also in the USA that helped me, print my boards that I design on computers. So I was pretty much geeking throughout then, just designing chips, designing the power side, the microcontrollers I'm going to use, design those things. Pretty much that's what I was doing for a while, right? And then I noticed that one of the things I noticed is that because at that time I was building my own stuff. I was trying to make money by myself, trying to build softwares, trying to build solutions for for clients, right, and then make some money out of it. Which part of it worked, some did not work, and stuff. I now started, and then I had friends that were into software, right? And then I had a very close friend of mine, like a brother, also into software. So yeah, I started learning software. Started out first with building apps. Pretty much, I had this learning of designing boards, C code. It was just a full hardware guy, right? But then 2 years after, I became an hardware software guy, right? So somebody that I could just write a full software that lives on top of an hardware and then just leave it to work like that. And so, um, which is one of the things I've actually seen in embedded engineers today, which is that they're actually very restricted in terms of not being able to understand some of them don't even write software at all um in the sense of C code, right? Um, s- the way the way some of them pretty much write C code is actually very forgive me to say annoying in the sense where that there are some basic fundamental software paradigms that are missing, right? It's just okay. I just want to collect this thing and display it to this person. I display it to on the LCD. Those were the things that were working for us back then. Just carry some Arduino codes and then just manipulate it and stuff like that. But it's much more than that, right? Everything is much more than that. You need to learn how the software works, right? And also how the hardware pretty much design it and stuff. Because I work with microcontrollers, right, a lot, and I am not into designing chips. I don't design chips. I pretty much just use chips on my board, right? I get the microcontrollers, microcontrollers. I understand how it works. I know that okay, this guy can help me with Bluetooth, can help me with stuff, and then I put it on top of my on my design like that, and I just make something out of it, and it works, right? So, uh, yeah, so right now, I pretty much classify myself as an engineer because I'm interested in hardware and also interested in software. So. Yeah, yeah. I don't know if it makes sense.
It makes perfect sense. So I like the fact that you highlighted that prior to joining this company, you were not programming POS terminals.
Yeah,
Again, what I want viewers to get out of this is that it's fine if you're working with some microcontroller development boards.
yeah,
That knowledge that you have in doing that is what you're going to carry forward to programming the next thing. It's kind of like saying, you were programming boards with expressive chips on them, and then you moved over to a Raspberry Pi.
yeah,
Raspberry Pi is a completely different silicon board, but that knowledge that you brought from the time with PIC and expressive was what you leveraged in order to program your Raspberry Pi and to build your products with that. Now, we were talking offline before we started recording about some products that you've built in the past,
yeah,
some uh, some things that you've tried your hands on.
yeah.
Do you want to tell us a bit about some of those so that I want you to go into mentioning other microcontrollers and things like that?
Yeah, yeah. Okay, okay, cool. Okay, so I've actually quite handled quite a number of things or in terms of projects. So when I was in school, I started building a lot of after I learned from Blessing. The name of my friend is Blessing Oyatope. I hope he's watching this as well. So yeah, he was one that taught me, like, brought me into embedded systems, and after that, I was just uh, doing projects for a lot of people, right? And I was making money as well in school. I was building projects for for guys that are doing masters, PhD and stuff like that. And yeah, just those projects were not even the things that interest me because it got to a time that I was even bored with everything because I was just repeating stuff, right? I pretty much knew all the sensors to use. I knew where to get them. it was getting boring. Those were not even the highlights. Actually, I think some of the highlights were when myself, Blessing Oyatope, and Oba Tekena, and then and Babatunde Otaru, four of us represented Nigeria in US at Microsoft Imagine Cup. So we won Microsoft Imagine Cup. We built a product called Humane, right, which is a device that allows blind people to operate smartphones, right? This was in 20, we started way back from 2013, and then, but then we finally won Microsoft Magic Cup Nigeria in 2016. And then, we got the chance to represent Nigeria in the world. But yeah, the world was, we didn't win in the world. It was one kind of forgotten it. Yeah, but anyways, yeah, we won in Nigeria and also we won in West Africa. That gave us tickets, all right, to the US. So and Humane was a very passionate store for us, for all of us, because we had worked on it for like 2 years. We had applied to Max. We went to Microsoft Magic Cup 3 years in a row. The third time was the Magic. The first two times were very tough. Yeah, we built stuff, but then it wasn't good enough. But then we just kept at it and stuff like that. So Humane is, yeah, it's close to heart basically, and also because it was something I did with my friends that I'm still connected with today. So it's something that I'm proud of. Yeah, I also did some robotics competition, right? Where myself and a friend of mine, myself and I was in a lab, right, back in school that did some, robotics project. They built some robots based on Tetrix, some Tetrix hardware, and also their chipset as well. And then we get to compete at World Robot Olympiad with other countries that also used the same Tetrix framework and everything like that. So yeah, I did this project as well with some friends, and yeah, in terms of we didn't at least we didn't win anything, but then it was I'm grateful to today for the opportunities that was given to me, right, to learn on those things, right. So yeah, yes, and yeah, Event One also is also another thing that started out as a project. In fact, the GitHub repo still alive to today. It was just an idea that I shared with a friend of mine, and we're like, okay, let's make something out of it. We built the version 2 of the Invent One board, and then version 1 was sent to US for fabrication, but it was expensive. So we did version 2 and we sent it to China, which was very good, impressive, and then yeah, it worked. So I'm also proud of Invent One. Yeah, yeah, yeah.
And
So
Invent One,
the
that's
device.
the startup for education, right?
Yes. And it wasn't just the board; it was the software as well. Because it was software. We had the software for pulling blocks together, and then the hardware, right? That downloads the code via OTA, and then runs the bin and stuff. So yeah, that's pretty much the end-to-end thing from Invent One. Yeah.
Okay. And you've been designing your PCBs, your printed circuit boards. How did you learn to design printed circuit boards?
Oh, okay. I made a whole lot of mistakes when I was learning back then. It was, and I don't think I could afford those mistakes now. I just thank God. I'm happy that it was back then that I experienced those mistakes. Right. There were times that I just got electrocuted a lot of times. I made a lot of mistakes, and sometimes uh, I already know what I'm supposed to do, right? But then I just end up doing the wrong thing, right? And then it just messes up everything, and it might lead to some, electrocution, like I said before. And then, yeah, and the thing will not work anymore. Something you designed so well, and then blah blah blah, it just stops working, pretty much. So I made a lot of mistakes. I sought help from a couple of friends as well, senior colleagues, right? that could help me. This was okay. So one of the reasons why I also it looks like I did a whole lot of things in school was actually that okay yeah okay yes I some people say they had triangle lives in school church blah 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 maybe I can say I had triangle life right but then but then yeah, for me, it was the laboratory, the hostel, lab, the hostel, the lab. So it's not triangle. It's maybe like just a line. Pretty much, yeah. And then it was just always, and I had a lot of friends that were like that too. So yeah. So I was always just at the lab and just working and trying to make things work. Uh, yeah. So I remember the time that I was testing out a project, right? And I got really mad that I should cheated. Like it was like I never forget it up to today, right? I made some mistakes holding some cameras I shouldn't be holding. Like even remembering it today is just like why would I make that kind of mistake, right? And yeah, so
So tell me, was PCB design a course for you? Was it something that was taught in school?
no, it wasn't taught in school. No, it wasn't taught at all in school, even though our lecturers wanted PCBs, but it wasn't taught. We also claimed to have like some tech to build the PCB boards, but no, they were not really functional. And they were just old ways. There were old ways of doing the PCB stuff, like this copper thing. But I never did that. I never did all those ones. What I did was the normal Vero board. I did Vero board and then I don't like to use the PCB board because uh, uh, some of the things I want to use right are very small, right, and then I couldn't find I can't normally find them. So what I do is is either I find like some replacements, right, and then just go ahead and ship them outside the country, that kind of thing. That's what I do, right. I have a friend of mine back then, right, that was very good with doing the whole process of the whole copper cleaning and doing spraying in some some chemicals like that. Yeah, he did it, he does it, and then it wasn't really fun for me actually. Like it was very repetitive and stuff. So it wasn't fun for me. But if I needed it, I tell him to help me do it, and then I arrange those chipsets on it and stuff. But there are some that I remember when I was doing a project with Admega 328. That's the same Admega that sits on the Arduino. Yeah, I've always the client wanted something that was really well packaged, well packaged and stuff. And because of the use case, right, I didn't want to solder it on the board. I had the soldered copy, right? I had the soldered copy, but the one delivered to the client was a real board, right? That we, I can send pictures of it. It did some SIM cards communication and stuff like that. And then it did some auto punching um, into some devices like that. I can yeah. So yeah. So I had to fabricate that one in the US. That one was fabricated in the US, and yeah. So I learned it myself, and then a couple of friends helped me as well. Yeah.
Did you buy any books to
Um,
help with
for,
that
for for
for the
PCB,
PCB? Yeah.
no. Okay. So the first thing is you necessarily need to have it on paper or somewhere, right? It's what you have on paper. That's what's going to sit on it on the
Hmm.
variable or your PCB board and stuff. And the thing you necessarily have to learn is design the circuit, right? That's pretty much what you have to learn. And
Hmm.
the other variable design, variable soldering, the other things are very manual things. Soldering, you have to learn how to solder. Um, yeah, which I learned it by watching people solder, right, and also by doing as well. Yeah, and so the system, the circuit design also I learned in books, and also I learned a lot of them by mistakes as well. Because when you make a mistake, you know that okay, fine, you never make before. In fact, I had a book, right, back then that once I've used a particular chip, I just know when next to just use the chip. I don't even check the documentation anymore. I know what this pin does. I square C and all the different communication with my other memory chip. Pretty much, you just put them together. SD or SDC, connect them, and then just fire the code, and then storing data inside of the memory, getting it back, read writes. It's some yeah. Those are the things actually.
So it sounds like with your PCBs, the boards themselves will get shipped to you, and then you do the soldering of the components on them. Is that what you were
No,
doing?
no.
Okay.
What I design actually um, is um, is what they call it. I pretty much when I'm done with the design, right? I do it on a variable board, right? I do the
Okay.
solder myself. I do the solder myself, and the reason why
Okay.
I do that, and what I do on what I do on the variable is exactly what I had designed on Ego. I use the software called
Okay.
Ego, Ego card,
Okay.
right? That's designed on my Ego, right? And just put things together. Now, at the final stage for me is actually like a fabricated copy that doesn't have the same size of the microcontroller you're using. It has like you know the it has the very tiny one, right? That you can't even solder pretty much. That sits that will now sit on your mic on your board, right? And then the whole power, you're not going to be using the normal electrolyte. Of course, it's the electrolyte capacitor, right? But then you're using the tiny one, right? You're not using the one that you basically go down. You're not using those fat ones, pretty much. So that's what I actually fabricate. I do the variable myself, and then I send the files to China or to US, and they help me. On the card, I've already put that. Okay, fine. This is the chip I want to be there. I've already designed how I want the whole circuit to be like and stuff, and then I send it over, and then a few communications back and forth, and then it's stuff is easy.
Okay. What advice would you give to anyone who's interested in becoming an embedded systems engineer, whether they're going to work with POS terminals or other microcontrollers? What advice would you give to them?
Okay. Thank you for the question. So the way I pretty much see it is that it's like layers, right? It's like layers. There's the OS layer, right? There's the communication layer, and there's the presentation layer, pretty much. Now we hardware guys in quotes, we pretty much we hang around the OS layer a lot, the OS and comms layer a lot, right? We don't really do so much of presentation, right? Some of us don't even need UI, UX, whatever. We pretty much just go and design our circuit ourselves, write the code that fires the microcontroller, right? And then, just put some LCDs there, and then just allow the thing to work. But the thing is that the world is changing, right? The world is changing a lot, and even faster actually than we even think it is, right? And a lot of work, as a lot of things that we usually do before, right? Those things have now been automated, right? Those things have they've been automated, and you need to pretty much go higher. You need to go to a higher level to be able to, even do something much more interesting. What I mean is this. So, for example, you are good with a particular chipset. Say, for example, you are good with a PIC 16F 877A, for example. You need to know that there's another version of that microcontroller, right, that they've done that is even far better than it. And that's what you should be looking at actually. Right. We have microcontrollers today that can actually do Bluetooth, they can do Wi-Fi. And those are the kind of things that we should be working with. And the thing is, once something does Bluetooth, once something does Wi-Fi, um, one of the things that will help you to even understand how it works more is to be able to build things to counter it. For example, You need to be able to build a client, for example, that can, have a that can actually that can talk to your device via Bluetooth. You know, these are basic software things. It's not now. It's not like, okay, you've designed the chip works here. And hardwares are fairly static. Once you've designed them, fabricated them, you turn it on, it will still do what it did 10 years ago, it will still do it today. Right. So they are very static. And what are you going to do after you've done the chips? Or after you've designed the board and stuff? You need to, be able to go ahead to the presentation layer. How do I present this to the client? How do I present this to the customer? And that will force you to learn, to learn software. It will force you, right? You don't necessarily have to be perfect at it. You just have to be able to build something that someone else can say that, oh, I understand how it works. I can even make it better, that kind of thing. And I think that was what I was doing a lot back then, which was the software doesn't even have to be perfect when I do it. But then, like, a friend of mine will understand what it means. Right? You understand that, oh, yeah, I get what it's doing and I can even make it better and stuff. So for me as an hardware guy, when I was building hardware, I was full of ideas. I was full of ideas, a lot of ideas. Sometimes there was a time that I was a full hardware guy, and there was a time that I was now dabbling into quite a number of softwares, writing C sharp, Java. And one thing about C is that if you learn C and you're good at C, other languages become pretty easy. Trust me. Because yeah, trust me, because everybody has, even though they are OOP, it got its origin from functional programming. It's just the data abstraction that is just different, right? So if you learn C, you are in the know. Even that's why quite a number of universities, quite a number of universities like outside the country, for example, they teach their students how to use C, and they wanted to be better at C. And yeah, if you use C and you're good at it, you are just know that you are in good hands and you've done some good stuff. So just be able to learn other languages, and yeah, I think they'll just you make a lot more. You'll be far far better. That's what I think. Yeah.
Okay. Thank you so much, Victor, for this opportunity. Thank you for your time. Um, yeah, we've come to the end of the interview.
Thank you so much.
So, yeah, I look forward to future. I look forward to future events that we'll organize,
Yes.
most likely online. But yeah, I'd love you to talk about PCB design at some point later in the year. Yeah, as well as other things, the difference between programming POS terminals and regular microcontrollers. Because I think with POS terminals, you're probably not doing GPIO as much as you would with microcontrollers.
I know at all.
Yes.
Yeah.
Okay. Thank you so much for your time.
Yeah.